Hello students. In the previous video we had discussed distance and displacement. I hope you have taken down the notes of distance and displacement. This video also I have made in the form so that you can copy down the notes. In this video we are going to discuss the types of motion based on the distance covered and the time traveled. On the basis of that we have two types, uniform motion and non-uniform motion. The definition of uniform motion is: if an object covers equal distances in equal intervals of time, it is said to be in uniform motion. That means here the speed is constant. For example, movement of hands of a watch, rotation and revolution of Earth. In both these cases, it is constant. Non-uniform motion: if an object covers unequal distances in equal intervals of time, it is said to be in non-uniform motion. For example, a ball falling from a height, a car moving on a crowded street. Here the speed is not constant. Furthermore examples: the movement of clock's hand and the movement of pendulum is the example of uniform motion. A movement of an asteroid and the bouncing of ball is the example of non-uniform motion. I hope you have understood uniform motion and non-uniform motion. Now next is mind map. This is just the summary of what we have learned till now. Motion, two types, uniform motion, non-uniform motion, the definition, and then how it is measured, distance and displacement. And what is distance and what is displacement we have covered in this slide. Now we are going to discuss two new topics, speed and velocity. First we will talk about speed. Speed, as you have learned in your lower classes, speed is the distance traveled by the object in unit time. That is called speed. The formula for speed is distance upon time. The SI unit of speed is meter per second. This is the international unit of speed. There are many other units, centimeter per second, kilometer per hour, but we have the SI unit is meter per second. Then speed can never be zero. If it is in motion, an object is in motion, speed can never be zero. It is a scalar quantity, that means only magnitude is known. For non-uniform motion, we calculate average speed. Its formula is total distance upon total time. This is a new term for you, velocity, that is speed with direction. Velocity, the definition is the displacement of an object in unit time or the speed of an object moving in a definite direction is known as velocity. Here, along with speed, direction is also known. The formula is velocity equals to displacement upon time. SI unit is same as speed, meter per second. Velocity can be zero as displacement can be zero. It is a vector quantity, which means it shows direction as well as magnitude. The velocity of an object can be changed by changing the object's speed, direction of motion, or both. Now during uniform motion, the velocity remains constant with time. That means there is no change in velocity. So in this case, the change in velocity will be zero because the velocity is same. Now in non-uniform motion, the velocity changes with time. Here the change in velocity is not zero. So how to calculate that change in velocity in non-uniform motion? For that, we have to introduce another physical quantity called acceleration. Now what is acceleration? The rate of change of velocity per unit time is called acceleration. Acceleration, the formula is final velocity minus initial velocity upon time. Symbolically, it is denoted by A equals to V minus U upon T, where V is the final velocity and U is the initial velocity. SI unit is given by meter per second square. It is a vector quantity. Now there are types of acceleration. Positive acceleration means if the velocity of a body is increasing with respect to time, we call it as positive acceleration. For example, a train leaving station. Negative acceleration. If the velocity of a body is decreasing with respect to time, it is known as negative acceleration or retardation. For example, applying brake to a car. Now there are other types also, that is uniform acceleration. Uniform acceleration means if an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then it is said to be uniform acceleration. For example, an object falling freely from a certain height. Non-uniform acceleration, that is the next type. If an object changes its velocity at a non-uniform rate, it is said to be non-uniform acceleration. For example, a car moving on a crowded street. Now we are going to discuss the symbol and SI unit of different physical quantity that we have learned in this chapter. First one, distance displacement. It is denoted by S, derived from a Latin word spatio. Its SI unit is meter. Next, speed or velocity. It is denoted by V. The SI unit is given by meter per second. Then final velocity denoted by V, SI unit same as it is also velocity, meter per second. Then initial velocity denoted by U, its SI unit is meter per second. Then acceleration, A, SI unit is meter per second square. Lastly, time, T, SI unit is second. So you have to learn these symbols and their SI units